Hello, everyone, and welcome to this webinar in collaboration with Codestryke. Today, our topic is OT and IT and the role of OTA software updates. Now, next slide. Yes. So here you can have a look at our agenda for the day. You have like a first track introduction, then controls automation updates, scalable industrial connectivity, an introduction of Mender, and then last part will be Q&A. So we are joined today by our three speakers, Aysin Stenberg, co-founder, CTO, and product manager here at Northern Tech and Mender.io, and Philip Meyer and Benedict Miller, respectively CEO and CTO at Codestryke. That being said, I will now leave the floor, or the screen, more like, to Benedict. So thank you and enjoy.
Yes, let me first get a little introduction about Codestryke. I am Philip Meyer, one of the co-founders of Codestryke, and as Valeria already said, CEO at Codestryke. We are an industrial IoT service and software company. Usually we work together with partners such as Mender, and we try to serve our clients in an end-to-end way when it comes to delivering and implementing industrial IoT solutions. We are a quite young company, 3.5 years old, with 16 employees in our 2 locations in Munich and Düsseldorf. And yeah, we are partnering with various technologies such as, for example, Siemens MindSphere, Software AG, Cumulocity, or Mender when it comes to OTA updates. And yeah, I will give a little introduction of what our industrial projects with machine builders can look like. And then Benedict and Aysin will take over and dive deeply into the topic of OTA updates. Yeah, and on the next slide, you can see one of our example projects. This is an industrial IoT solution that we jointly developed with the company X1. X1 is a machine builder that produces large industrial 3D printers. So they have 3D printers that make layers of sand, and they put activator and binder on it, and then some kind of form comes out. And these forms are usually used in the area of research and development. And this is quite a new and innovative process that sometimes also fails and you produce scrap. So, and if you produce scrap, you lose about 20 to 30,000 euros in just consumption material, and you also waste machine hours. And this is something you, of course, as a machine operator, try to prevent. And together with X1, we developed the X1 Scout, which is a cloud solution that runs, in this case, on Siemens MindSphere. You can access it through the web or through an app on your iPhone or Android device. And what it does, it tells the machine operator information about the current status of the machine. So which layer is currently printed, what status is there, what is the fill level of the consumption material. You get alarms when the fill level is too low, so that the printer never stops, because when it stops for more than 15 minutes, you will just produce scrap and waste a lot of money. And yeah, we also implemented an optical defect detection. So there's a camera inside the printer that can see whether what is now being printed is what should be printed. And if that's the case, everything continues. And if that's not the case, the machine decides whether to adjust the production process or to stop it in order to prevent producing more scrap and wasting more money. And yeah, this saves a lot of money for machine operators. It's an industrial IoT solution for a machine, and yeah, it requires proper use of technologies. And I think Benedict and Aysin will give an introduction of how OTA updates and works in the terms of, or in the context of, automation and industrial solutions. So yeah, I will now hand over to Benedict.
Yeah, thank you. My name is Benedict, as already introduced. And yeah, I think we we'll start with the perspective, the kind of historic perspective from the automation world on doing any updates. And the general rule in automation is never touch a running system, and especially never ever update PLC software or firmware. And you might now ask yourself why. And the reason for that is that to update the PLC, to update the firmware or the software, you need to stop the production process. And this can be done during scheduled maintenance, of course, but then you run into a second problem where the startup of the production process might not work. So because PLCs are often not power cycled for months or even years, when you do power cycle them or stop them for an update, you kind of lose, some of the time you lose important process parameters that you then will have to dial into under time pressure again to try and get the machine to start up again. And another problem is that usually you can't really test your PLC program or the new firmware beforehand together with the machine and the physical process, because for that you would need to have an almost perfect digital twin. And a lot of companies, I would think about 95%, don't even have any kind of physical simulation to test their PLC programs before they are deployed. And if you then deploy the PLC program or the firmware update to your machine, you don't really have an easy way to do rollbacks. So you can't roll back physical damage, of course. If you cause a crash with the update, if a firmware bug causes a problem in your PLC program, then you don't really have a chance to undo that easily, and you will have to spend a lot of time and money repairing the machine, and which of course also causes unexpected downtime. And these reasons are very valid, and there also wasn't really a reason on the other side to do any updates at all until now. But with the trend of industrial IoT, this of course changes, because now everyone likes to connect their machine to the internet. And one way to do that is to directly connect the PLC to the internet. And different vendors have different methods for connecting the machine, the PLC, to the internet. For example, with Siemens, you can directly call publishing functions for publishing data to the cloud from the PLC program. Other vendors like Vago or Bosch allow you to run Docker containers alongside the PLC. And this might be the cheapest solution and the most convenient solution, because you can just use existing hardware. This also causes trouble down the road. Mainly the two most important problems are that because you can't update a PLC, you also can't update your IoT connectivity software packages. And with this, you have the public security flaws that are already published by security researchers, never get patched, and the attack surface of the PLC increases over time. And the second problem is that the PLC as a whole system is often made for interoperability above any security measures. So the PLCs and the field devices often allow unauthenticated access, configuration, and data exchange, because for some communication use cases, encryption or authentication just isn't possible, because the communication has to be fast and deterministic. And from a historic perspective, the automation world kind of doesn't really care that much about security from a background perspective. Yeah, so the question is now, how can we solve that problem? And the easy answer is that you must stay away from connecting the PLC directly to the internet and always use a dedicated gateway. And with a dedicated gateway, you have the possibility to split the networks. So you have a separate network for the machine with all the unauthentic communication going on. And then you have another network that establishes the internet connection or the connection to your company network. And You also now have the possibility to use just the native protocols to talk to the PLC. So your PLC doesn't have to be anything fancy. You can just use the standard automation protocols like Modbus or 7 communication and talk to the PLC that way. And the most important point, of course, is that you now have a system that's fully updatable, because you can reboot the gateway in the middle. You can do full operating system updates and allow robust and secure over-the-air updates. You only lose a minimal amount of data if you power cycle the gateway once in a while during an update. And yeah, we at Codestryke have a lot of experience with that kind of connectivity scenarios, because we also have a software that's made for connectivity to PLCs, frequency converters, energy meters, or sensors, and which allows you to send data directly to any cloud you like, and also remotely configure that connection to the cloud from a central configuration platform. And this solution is hardware agnostic, but still needs to implement, of course, the over-the-air updates. So the over-the-air updates at Codestryke topic is kind of split into two things. We, with our connectivity software, VirtuaLink, we enable secure, scalable, and reliable connectivity to PLCs and field devices. And then under the hood, Mender does all the heavy lifting to allow robust over-the-air updates, which is very important for our industrial customers to have the process of updates secure and reliable. And I think I will now hand over to Eystein, who can tell you all about how Mender does the heavy lifting under the hood.
Perfect. Thank you, Benedict. It was very interesting to learn about industrial IoT use cases. So I'll talk a little bit about the background of Mender and what we saw when we started Mender. I think it was back in 2015 or so. At that point, there were mostly homegrown OTA solutions for the companies that realized that they needed to do OTA. There are quite a few challenges building it yourself. It looks quite easy in the beginning, but it gets very expensive, and it takes the focus away from your application logic. In this case, managing the plant and figuring out what is going on in order to optimize the production. So that's what you should focus on, and not how to build the OTA infrastructure. So we wanted to build Mender in such a way that it could be reused by all companies, and it's based on an open core model. There were and there are still other open source alternatives available, which are good as well. We focused on being end-to-end and also have to meet enterprise grade requirements, primarily around security. So similar to Codestryke, we try to solve the problem end-to-end, and not only, for example, offer a client solution or only a backend solution or something like that. It's meant to solve the entire OTA use case end-to-end. So along the way, we have also this cloud providers that you're probably familiar with, which also offer some building blocks that you can build your OTA solution on top of. But these are not built for purpose of doing software updates. So it would be a bit similar to homegrown solutions. And then you have proprietary platforms. Again, we want Mender to be available to everyone with an open core model and a big community to avoid lock-in. That would be a challenge longer term for companies. So the next slide, please. I'll give you a little bit overview of what Mender is for those of you who are new to it. So it consists of a server client or client server solution. We mean that Mender is secure and risk tolerant, efficient over-the-air software management for connected devices. And we do this by having the server solution where you can manage all the all the clients and with the web UI as well. And then you have the clients that are running on the devices that regularly check in with the server. And there are no open ports on the clients, only uses encrypted authenticated connections bidirectionally. So we're very careful with the security aspects around this. Because it's very security sensitive use case, obviously. That's the challenge we saw frequently with homegrown solution, is that security is a bit back in mind. You just want to get the software to the device, but once you have a vulnerability in the OTA infrastructure, yeah, everything is lost basically. So we are very careful with this. Can you move to the next slide, please? Thank you. So just to cover a little bit on the robustness and security aspects, Benedict mentioned it a bit earlier, but we support a dual root file system or system updates. You can see it at the bottom right there. So there are actually two systems running on the device. There's one that's running and there's one that's not running, and we update the one that's not running. So this is a pretty well tested and proven design in general that ensures that your device or product will always get back up online. So even if you lose power when you upgrade, you will have a working system because you're not updating the system you're running, and you will simply boot back into that one. And then, yeah, obviously we provide integrity checking and grouping as well to ensure the robustness. So robustness is a key focus area, the most important one for Mender, and we have several features to ensure that. And it basically means that it works in unreliable environments, both when it comes to network and power. It always comes back online. We focus a lot on this. And then security, of course, we have authenticated communication encrypted with TLS and various ways to authorize the devices once they connect. So you can use mutual TLS, or you can approve the devices as they come, depending on the workflow that you use for your production line. And obviously, we also support image signing, which is a different type or different layer, I should say, in the security model. Next slide, please. If we dive a little bit into the customizability, which Benedict also mentioned, you can do system updates and application updates with Mender. So they work in similar ways, but for application updates, we have something called update modules that will allow you to support a variety of application updates like Docker or Debian packages as well. So it's quite customizable in terms of which software you need to update. Next slide, please. And even when you have chosen the software, the type of the software you need to update, you can also insert scripts, so state scripts, which Benedict also mentioned earlier that you use. So these are similar to pre-post install scripts that you would perhaps be familiar with from package managers, but they're a bit more general purpose. So you can insert them between any state, not just before and after the installation of the software. But you can, for example, use them to ask the user if they want to update before you download the update. So it can be pre-download scripts as well. And obviously you can do application migration and even test the update after it's been rebooted into the new update. And you can roll back if some of the tests, or even if the user doesn't like the update, you can go back to the previous version. Next slide, please. And then we have, I won't cover all the features and use cases, but just one example of scale is phased rollout, and this is sometimes called Canary Releases. And the purpose here is that even if you have a large fleet, and even if you did all the testing you needed, and you did your due diligence, sometimes things happen anyway. Maybe the software doesn't perform as well, or if you put it in a different environment, it's not behaving to customer expectations. Maybe the customer doesn't like the new UI even, or gets confused. So a lot of things can go wrong at every step. So at the last step, when you deploy the production software, you can phase it out like it's illustrated on the top right there. So you can start with, let's say, 5% of the devices, wait 2 days or 3 days. You can choose how long you would like to wait for feedback from the market, so or from your customers. So if you get higher volume of support, you can abort the update process, or you can proceed to the next step if everything looks good. And scheduling is also a part of this too. It's a separate feature, but it's you can combine them so that you deploy the updates once the devices are not in use, usually at night. Sounds like during manufacturing there isn't much downtime in general. But, okay, next. Yeah, thank you. So this is the last slide. Just a quick overview over the different offerings we have at Mender. So we have an open source version. It's an open core model, as I mentioned. This is freely available to everyone to use and integrate. Very permissive license under the Apache license version 2. So you can even modify it and redistribute it. We have the basic plan, which is same feature set as the open source one, but we host it as a SaaS offering. Then Professional has some more features relating to primarily around automation and automating deployment management. You can see it at the bottom there. So scheduling deployment, automatically retrying deployment. So basically things that would save you time and try to avoid errors during the update process. And then finally, the enterprise is the highest tier, which will include primarily risk management features. So lowering the risk of the update in terms both of security and operational risks. So for example, phase rollouts, as I mentioned earlier, is part of the enterprise plan because it lowers the risk that you will have a bad experience to your customers when you deploy the OTA. You will have the chance to abort it if something goes wrong. And with that, I think we have finished this.
Nice, and thank you so much for the effort and time and the beautiful presentation to all of you guys. And wish you the best in the future, and hopefully we can have other webinars like this.
Thank you for organizing it.
Yeah, thank you.
Thank you.